Let's find f of g of x and also g of f of x. So first let's find f of g of x, and this equals f of replace g of x by the expression x plus 3 over 7. So it is f of x plus 3 over 7. Now we have to determine this f of x plus 3 over 7, and this equals, we have to replace x in f of x by this expression x plus 7 over, I'm sorry, x plus 3 over 7. So therefore this becomes, we have f of x equals 3x minus 7. So 3 times of, I replace x by x plus 3 over 7 and then minus 7. So let's simplify this. We can write this as 3 times of x plus 3, and this is over 7 minus 7. So we can do the distribution. That is 3 times of x is 3x plus 3 times of 3 is 9, and this is over 7. And I'm going to write down this 7 as 7 times of 7 over 7 so that we get common denominator. And this equals 3x plus 9 minus 7 times 7 is 49 over the common denominator 7. And so this simplifies to 3x plus 9 minus 49 is minus 40 divided by 7. So this is f of g of x. We will now find g of f of x. So g of f of x, and this equals g of, replace f of x by the expression 3x minus 7. So we have to determine g of 3x minus 7. And this means we have to replace x in g of x by this expression 3x minus 7. So therefore this becomes, I replace x by 3x minus 7. So we get 3x minus 7 plus 3, and this is over 7. And so this gives 3x minus 7 plus 3 is minus 4, and this is over 7. So this is g of f of x, that is 3x minus 4 over 7. Okay, now that we have determined the composition of the function, that is f of g of x and g of f of x, we will now determine if f and g are inverse to each other. So considering f and g as functions, if we say that g is the inverse of the function f, then this has to be true. That is f of g of x, this should equal x. And also if we say f is the inverse of the function g, then we should see that g of f of x, and this must also equal x. But clearly, which we have already determined, that is f of g of x and g of f of x, these two are not equal to x. So therefore we say that f and g are not inverse to each other. F and g are not inverse to each other.